Okay, this is called the remainder and factor theorem. It's pretty simple. It's basically saying if I have something like we did in the last lesson and I divide it by a binomial x minus b, the remainder is that when you plug b into the problem. So if we were to do for instance, the one from the last lesson, the remainder was 6. If we would have plugged in that coefficient of 1 into the thing, you would get a number 6 out. Now the nice thing is the factor theorem, this is more important. If it's a factor, hence the factoring, that means that when you plug in this number, b, or letter, then you get a 0 out. It's one of the zeros of the graph, one of the zeros of the polynomial. Hence why when we were factoring with graphing and quadratics and all that, we always set it equal to 0. To solve, we want to know what those zeros are. Alright? So, let's factor the polynomial completely, given that we know one of the zeros is negative 3. It tells you that the negative 3 is a 0. Okay? Why is that important? Because we know that if we divide by this factor, we divide out by that factor, this is the same thing as saying like I have a factor of x plus 3. Okay, remember that? The 0 here would be negative 3. So if I'm synthetically dividing by negative 3, you should get a remainder of 0. That's what this is telling you. We have a remainder of 0. It is a 0. So let's see what happens when we factor this. I have a negative 3. Again, you should know how to synthetic divide by now, hopefully. Again, we couldn't factor this nicely because grouping wouldn't work out. So this is not a grouping one. So let's do this first. 2 times negative 3 is negative 6. Add those together, you get a positive 5. 5 times negative 3 is negative 15. Add those together, you get a positive 3. 3 times negative 3 is negative 9. Sure enough, when you add those together, you get a remainder of 0. So first of all, we did it right. Because again, I'm telling you it's a 0, so you should get a remainder of 0. Now, what that means is, if I'm factoring this, it means that I basically divided out an x plus 3, because that's what I divided by with synthetic division, and I ended up with 2x squared plus 5x plus 3. Now it says factor completely. When you get down to a quadratic, you have to see if you can factor this more. Well, sure enough, if you use splitting the middle term / Batman, you can factor that. I'm going to just do guess and check real quick because it's faster with the smaller numbers. This has to be a 2x, this has to be an x. One of these has to be a 3, one of these has to be a 1. If I put a 3 here, it doesn't work. The 3 has to go there. 2x squared plus 3x plus 2x is 5x plus 3. And now it is factored completely. But this would have been hard to do from just this. We would have had problems because there's no real way to start off unless you know what one of the factors is. Okay? And we're going to tie that into the next lesson where we're actually going to find that factor and then go through. So we're like building on up to what we're going to be doing in the next lesson. Alright, now, given one 0 of a polynomial, find the other zeros. So now I want to factor and solve in a way. Okay, so I'm going to take this step I'm going to take it one step further. So I know my 0 is 2, which means that the factor is x minus 2 here. We already know that. There are 2 other answers to this problem because it's an x cubed problem. So we have to figure out what that is. Over here, the factor is x plus 3. Again, 2 other answers because it's a cubed. So here we go. Let's factor this. So we get 2. Now some of you guys might be asking why aren't we using the change sign? Well, because I'm actually giving you the number in this problem as opposed to the factor which I gave in the last lesson. The last lesson, if I gave you that, you had to flip the sign. Here we don't because I'm giving you what the 0 is. You're always dividing by what the 0 is. So we have a 1, negative 2, negative 9, and an 18. Bring down the 1. 2 times 1 is 2. Add those together, we get a 0. That helps us a lot. 0 times 2 is 0. A negative 9. Negative 9 times 2 is negative 18, which again gives us a remainder of 0. So we know it checks out. That is a 0 of the problem. Now, I'm going to rewrite it in factored form. So f of x is equal to x squared minus 9 is one piece. And the other piece, which we just divided by, is that. You can also factor it a little bit more. Okay, so all that I did was I took this original problem, and you could have actually factored this by grouping and got the same thing. But I took the original problem, synthetically divided out the x minus 2 part, so I pulled this out of there, and you are left with the x squared minus 9. And now I just factored it. So now I want the zeros. So I want to set these equal to 0. So I want each piece equal to 0. So x plus 3 equals 0. So x equals 3. X minus 3 equals 0. And x equals negative 3. Or the first one should be negative. The second one should be positive. Okay. And sure enough, we found the other roots. Now you can tell me, again, all the roots would be also 2, but here are the other 2 roots. These are the last 2. And sure enough, we have 3. We have 2, negative 3, and 3. Alright, let's do the last one and see what we get. I'm dividing by negative 3 into, and again, if I'm telling you this is a 0, you should get a remainder of 0. If you don't, you did something wrong in the math, especially if I tell you it is a 0. 3 times negative 6, or negative 6 times negative 3 is negative 18. Negative 8. Positive 24. Positive 3. Negative 9, which gives us our 0. Okay? So, this would be the function in factored form. We have our x plus 3 we just divided out. And we're left with 6x squared minus 8x plus 3. Well, you can't factor that nicely. In fact, that will be imaginary. You could always quickly check if it's imaginary or not, or nice, by plugging this into your calculator and see if it hits the x-axis. If it doesn't, then you have 2 imaginary solutions. Alright, so we're going to set these 2 things equal to 0. We already know that this is 0, negative 3. So we're just solving this piece. How can we do that? We can either use quadratic formula or completing the square. I'm telling you right now, with this 6 out in front here, completing the square is not fun. So let's do quadratic formula. I'll do that over here. I'll make some space. X equals opposite b, so positive 8 plus or minus the square root. 64 is b squared minus 4 times 6 times 3 all over 2 times 6, which is equal to 8 plus or minus the square root of negative 8 all over 12. Now, again, I noticed some of you guys would now cancel out the 8 and the 12. You cannot do that. You need to be able to, if you have a plus or a minus on top, you have to have a number in front. You can't cancel unless you can split it into 2 fractions and cancel them both. Alright, so, but I can fix this into, this is 2 root 2, but it's also an I. So it's x equals 8 plus or minus 2i root 2 all over 12. Now I can take a 2 out of everything. So my final solution, my other 2 zeros for this problem are 8, oh no, as I take a 2 out, it becomes 4 plus or minus I root 2 all over 6. And that is it. I found the other 2 zeros. They're both imaginary, and then the third 0 is negative 3. Okay? So again, this lesson was basically taking synthetic division, the next step, and seeing how we use it to split apart our polynomials. Okay? Next lesson will be throwing it all together and getting all our information.